Alright, in this video, we're going to hopefully finish up filling in all these columns and stuff like that and doing all the Riemann sum values. Just to review, we went and we put in this equation for this and then dragged it down. Now I got to go and I got to put y2 in here and evaluated all these different x values. So I am going to type equals, oops, I'm going to get it, yes, doing it, equals -2, so I'm pulling off these guys, sine, so I need to hit multiply, otherwise the computer gets confused, sine of, now I got to take my x value, I got to divide it by 2, and then I need to subtract 3.1415 over 6, close parentheses, plus 2. Now hit enter. And it gives me that value. I'm going to go ahead and take that and drag it down, all the way down to my 39. Fills in all those values. So now what I have is I've got this y1 equation here for all of these different x values. Oops. And then this y2 for all the same different x values. Remember, if I was doing the integral, which would give me the continuous theoretical volume, is what we refer to it on your sheet as, I would do this integral. If I want to find the volume of one of the slices, well, I do the root 3 over 4, which is my coefficient for equilateral triangle, and then I subtract these two and square them, multiply by the root 3 over 4, and then multiply by the delta x, and that gives me the volume of each slice. So I'm now going to type equals SQRT is how I do a square root of 3 over 4, and I'm going to go times, open parentheses, and I'm just going to select this, and I'm going to subtract, and select this, close. I'm going to add it to the second power, and then I'm going to multiply by my change in x, which is the 0.175. Now, I'm not going to use this, because if I use this right here, then in the next cell, it's going to take this. So I'm actually going to type in 0.175, because I wanted to use that all the way through. So times 0.175, and now hit enter. It gives me the volume of that slice. Now I'm going to drag that down to here, and I'll get rid of this formula for now. So I've got all these different volumes, all these different slices. Now I'm going to make the computer add them all up for me. How's my time? One thing I'll point out is that this and this, they should really both be 1.5. The reason they're not exact is because I used an approximation for pi. I used 3.1415. If I'd actually used pi, or pi over 6, whichever it is that I wanted to use there, then I would get an exact number, but it's close enough. So now what I'm going to do is I want to add up all these guys here. So I'm going to come to this, I'm going to go equals, I'm going to type sum, open a set of parentheses, and I'm going to come up to here and drag down. I'm going to go all the way down to that 0. And you can see right here, it's got what I'm typing into, even though it's covered up there. So I'm going to close my parentheses and hit enter. And I'll add it all up. And that's my the sum of all of my different slices added up. And that's the information that you need for your project. You need all of this right here. That's one part of your project, having all those amounts down to there, and then adding them all up and getting that number is another part of your project. So as you can see, using the spreadsheet here definitely simplifies the work a lot. You can imagine calculating all of these 39 different volumes all by hand would probably take a long time. So it's nice to be able to take advantage of the spreadsheet when we can.